Um, okay. So today we are going to discuss about big data analysis. Okay, and how we can, what are the options SAS provided to do big data analysis. Okay, so mainly, is my screen is visible?
Yes, sir.
Okay, sure.
Yeah.
Okay, so mainly, we are hearing this term, big data or data science. These terms are actually familiar these days. So first of all, what is big data? Okay, we'll start from there. What is big data? Actually, big data is mainly people say is large data. Okay, large volume of data as big data. Actually, it is not. Okay, so there is no single definition for big data. It's actually, big data is a term that is actually a collection of data sets. It's too large and too complex. Okay. So it's not about the volume of the data or not about the size of the data. Normally, there is a misleading thought like, okay, if the data size is too large or if number of rows uh, a, exceeds than a Excel sheet, then people normally say that it's actually big data. Okay. Uh, so actually, big data is consists of these three V's. Okay, it's actually volume, velocity, variety. Okay, so there should be a, large volume of data, and the velocity of the data also is very high, and there is lot of variety or different type of variables are there. Okay, so this is actually called big data. Okay, this is a sum total of these. Okay. So nowadays, actually, if you look at the data journey, then actually 50 years back, what was the data size the entire world has generated? Actually, that is generated by a single day now. Okay. So that much amount of data is actually generated every single day. Okay. So so every day. We can simply imagine how much data is generated in a single day. Okay. Okay, we can go back to 10 years also. So before 10 years, when not even 10 years, when Android is introduced. Okay, Android phones are introduced. Before that, actually we were using small phones. Okay, not smartphones. We were using some feature phones. Okay, while using these feature phones, mm, we were using data also. Okay, there are some feature phones they support data also. So there we were using GPRS or we were using 3G data. Okay, initially it was GPRS. Okay, then Edge come into place, and after that 3G came. Okay, so during those times, actually, if you use phones those times, and you can, you know that like we were recharging for 100 MB or 200 MB data, and that is also for a month. Okay, so actually, for today's kid, it's actually imaginary thing only. Okay, even it's an imaginary thing. They cannot imagine that if you are using 200 MB data for a month, actually it's something unimaginable. Because today within 5 minutes, they simply use 200 MB of data. Okay. So yeah, after that 3G comes into place picture, and we were using 1 GB of data for a month. Okay, we got a little more data for a, good amount of price. Okay, so and, I still remember for only 1 GB of 3G data, I spent 98 rupees. Okay, uh, okay. So that's for a month. Okay, so that was the case there. And so every day, every month we got 1 GB of data, and we were using that particular 1 GB of data. We are handling the data as a precious thing. So it's a valuable thing. If we complete 1 GB of data, then we cannot use the data for the remaining month. Okay. So that was the case. Actually, after Android and smartphones introduced, and many applications were introduced. Also, uh, some good mobile plans introduced. Then the data limit increases. Okay, and when 4G comes into picture, Geo introduces a 4G plan with unlimited data. Then the storage changes. Okay, actually, we got 1 GB of data every single day. Okay, now we are using 2 GB or 3 GB of data per day. Okay, and the corona situation actually changes that also, because now many people are working from home like me, and students are actually taking online classes and all, and they need large amount of data every single day. Okay, so even 1 GB of data is not enough for a single day nowadays. uh, so if you think, on an average 40% of the world population is using uh, a smartphone. Okay, let 40% of the world population is using a smartphone, and uh, they are using, on an average they are using 1 gigahertz of gigabytes of data. Okay, 1 GB of data a single day. Then you can imagine how large volume of data is creating every single day. Okay, okay, that much data is actually generating every single day, and there are a lot of variety of data. Okay, we are doing online shopping, we are surfing in the internet, we are searching in Google, we are doing some classes, or we are doing some transactions, or we are ordering food through Swiggy or Zomato, and we are booking a cab, or we are booking some flight. Okay, so lot of variety of data is actually generating from the smartphone itself. Okay, from the smartphone you have. So initially we were using megabytes of data, and then it changes to gigabytes of data. Now terabyte and petabyte of data is actually consuming or generating every single day. Okay. The scenario which I explained is only related to smartphone users, okay, or individual persons. Okay. Apart from these, the companies, okay, the business teams, they are also generating the data. Okay. So they are also generating the data. They are also generating, like if you go to Amazon website, okay, a lot of searches and lot of transactions are, and a lot of orders are placed in Amazon every single day throughout the world. Okay, so a lot of data is actually generating by the companies. Okay, like Amazon, IRCTC, or Google. Okay, or Yahoo, whatever. So a lot of data is actually generating, and these data are very big in volume. They are very they have a good velocity, and they are very much uh, different. Okay, each data sets are actually very much different from each other. So there are a lot of variety. So we can call big data, big data, some of these three V's. Okay. And for handling this big data, we need okay. While handling this big data, we have these problems. Okay, one is the data is actually large in volume. Okay, so if the data is large in volume, then automatically the processing and all will take more time. Okay, and the data is actually have different varieties of information, or different fields are there. So there are some complexity in analyzing or processing the data, and the ultimate thing is speed. Okay, for doing all these things we need speed. Okay, so while increasing data variety and volume, also the data complexity, we need speed. Okay, we need speed also. Okay. So if you look at this graph, it actually shows ERP. Okay, and then initially when ERP is only were there, and they are using some systems and also it actually generate megabytes of data. Okay, and when it comes to customer relationship management and all, and it increases. Okay, it actually handles of gigabytes of data. And when it comes to web and all, okay, it actually the data volume and data complexity, also the data variety is increased. Okay, so it finally reaches the big data. So we said we have three V's in big data. Okay, the first one is volume. Okay, volume, or we can call it as scale. Okay, so uh, first one is data volume. Actually, from the example, actually, the okay, from the example which I mentioned, during last 50 years or last 10 years, if you consider, the data is actually the smartphone data itself, or individual mobile or smartphone usage or phone usage data is actually exponentially increased. Okay, and it's still going on. Okay, anyhow, 5G is going to introduce in India by 2022, and then also the data limit and speed will increase, so people will use more data. Okay, okay, so data volume is actually increasing exponentially. So initially, when we look at uh, 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 20th century, okay, in the beginning of 20th century, actually we have a little idea about the digital universe. Oh, we have some little idea about the universe. Okay, but after the dramatic change in our dramatic growth in technology, actually we can explore more into universe. Now a lot of telescopes are there, a lot of satellites are there, which are continuously grabbing the data from universe. Okay, so every second every second the data growth is actually exponentially changing. Okay, so okay, and also this amount of tweets in a day. Initially, when I started Twitter account, actually we were getting only little bit of tweets. Actually, a few of my friends, okay, like less than 10 of my friends were using a Twitter. Okay, but today, entirely the things is changed. Like every single thing, okay, every single incident in the world is actually appearing in Twitter. Also, the Twitter tweets are actually increasing. So everywhere, data is increasing nowadays. Okay. So these are some of the technology giants, and uh, they are generating this much of data every day. It's a statistics from 2020. Okay, last year only. Okay. So actually, Twitter is actually processing 12 plus TB of data, okay, terabytes of data. FB is actually producing 25 TB plus data every single day. Okay, and then this is actually Facebook is actually a single company, and Twitter is also a single social media platform. Then you can think how much TB of data how much TB of data actually Google is capturing or processing or storing every single day. Okay, so this is the statistics from 2020. Okay, okay, and if you look at this picture, you can you know what it is. This is a CERN's Large Hadron Collider. Okay, so this is actually they are doing many experiments in this Large Hadron Collider. So there also in a year, 15 PB of data is actually generating, and they want to process that much of data every single year. Okay, then if we come to the Earthscope, okay, Earthscope is actually world's largest science project. Okay, so they are also actually generating 67 terabytes of data. Okay, so actually everywhere, okay, all the science projects, all the technology related things are actually generating high amount of data. Then variety, okay, variety we can call it as complexity. Okay, so initially the data stored in a school, okay, means initially the usage of computer systems or internet was very low in early 20th century. Okay, 2000 and that. So I still remember when I go to school. Actually, we got a system. Okay, in our fourth standard, we have a computer class. Okay, and there actually we had a computer system, and that is installed by MS DOS. Okay, so okay, there actually that is the first time we see a computer, and there we have only MS DOS. Okay, everything we need to perform it by giving commands. Okay, so from there, actually, now the complex computer systems are there. Okay, we have supercomputers, and even when it was 2000s, early 2000s. The power of the supercomputers in early 2000s, actually we can perform those calculations or those experiments simply in our personal laptops nowadays. Okay, because the supercomputers in that time, okay, 20 years back, today's laptops are more powerful than 20 years back supercomputers actually. So that time it was supercomputers are used for scientific purpose and all. Uh, they actually used for scientific purpose and all. They were not using it for other other activities. Okay. So when it comes to variety, actually we have relational data now. Okay, we have transaction data, we have medical data, we have legacy data. Lot of data, it's a lot of variety data are there. Then initially, uh, okay, when we start, okay, I was a statistics graduate, so when I start my class, okay, when I start my studies in statistics, okay, after 10th and plus two, we have some basic idea of statistics or basic calculations or formulas in statistics. And after that, when I joined uh, my UG in statistics, actually, uh, my thought was like we are only using numeric data. Okay, we are only handling numeric data by statistics. Actually, after a couple of years or after a few months, actually I realized that the data is not only numeric data. Oh, the data we are processing is not only numeric data. Okay, nowadays we are actually processing a lot of text data. Okay, initially when I start studying statistics, most of the companies in around the world, they were using analytic technologies only to process the numeric data. Okay, but now it is not. Now the situation is changed, and now the scenario is completely changed. That advanced technologies are now able to analyze the text data. Okay, we can process the numeric data in large volume and large variety. We can also process text data. We can process image data, and we can also process the video data. Okay, moving data. Even live data also, or live videos also we can actually process. Okay, so Uh, there are a lot of varieties of data is there. Relational data, which are actually in the traditional data sets. And we can have text data, semi-structured data. We can have graphic data from social media network or semantic web or something. And we can have streaming data, okay, from YouTube or traffic cameras in the road. So from the channel network, okay, now okay, television network and all. So we have streaming data, and we can gather or collect data from applications. Okay, we can have public data as well. Okay, which we are connecting from online sources or satellites or some newspaper which are available in public. Okay, so a lot of variety of data is available nowadays. So to extract the knowledge so if you want to extract the knowledge regarding a particular problem in Amazon, we have to check at their transactional data. We have to check at their customer feedback data. We have to check at their uh, uh, Twitter account data. Okay, what people are talking about Amazon, and we have to look at their streaming data in their social media accounts and YouTube. Okay, so all these type of data we need to link together. Then only we can extract the or we can solve a particular problem. Okay, from the customer's point. Okay. So this is a single view of the customer. Okay, they are actually generating. Okay, even you guys are a customer. As a customer, you are generating lot of data. You are contributing lot of data every single day to the what? Okay. Then next thing is velocity. The third V is velocity. Data is being generated fast and need to be processed fast. Okay, so if you look at the stock market and all, actually there we have a lot of data generated in every single second. Okay, every single second or millisecond they are generating data. So if you want to give some outputs, or if you want to give a good output, then we have to process all the data that much faster. Okay, then only we can give latest update. Okay, so the information from the stocks or satellite, they are actually some operations in the medical field. Okay, so robotic medicine and all in that field also. Every single second or every millisecond we need to process a high amount of data faster, so then only we can give certain instructions and we can control everything. Otherwise a mistake in a single second or millisecond will drain your or will cause you loss of lot of billions of dollars also. No, okay, so two examples are there. Uh, e-promotions. Okay. So promotions are actually sending based on the current location, purchase history, and your likes and dislikes. Okay. And healthcare monitoring. Okay. Sensors which monitor your health activities. Okay. When you are in a ventilator or when you are going through a robotic surgery or so. So healthcare monitoring also need to process the data so fast. These are the examples of real-time or fast data. Social media, scientific instruments, mobile devices, sensors, and technology. So, okay. So, you might remember this slide. Okay, real-time analytics of decision requirement. Okay, from a customer or in as a customer, we have a lot of influencers around us. Okay, so we will get some product recommendation. Okay, and daily if you check your mails or so, you are getting some product recommendations there, uh, and it should be relevant. Then only people will, or customers will look at that recommendation. And improving the marketing effectiveness of a promotion. Why? it, because every promotion actually nowadays, initially the promotion is through uh, TV ads or newspaper ads only, so or radio ads. So every people see or listen to the same promotions. But now it actually changes. Okay, we have different promotion for different set of customers. So it actually changes. Okay, based on the customers, we are actually giving recommendation. So preventing fraud. Okay, that is actually a big challenge in the banking or finance industry. Okay, then learning why customers switch to competitors. Okay, so competitor analysis. Then friend invitations to join a game or activity. All these things need a real-time analysis and need to make decisions faster and process the data. And okay, so we talk about uh, 3 V's of big data, but somebody says that we have 4 V's. Okay, so first one is volume, then second one is velocity, and third one is variety. Okay, so these things we have already mentioned, and the fourth one is veracity. Okay, veracity. So veracity is data in doubt. Actually, this is the uncertainty due to the data inconsistency or data incompleteness. Okay, when it comes to a big data, actually there is a scope of lot of missing data or a lot of misplaced data or misentered data. Okay, lot of problems are there. So we many people are saying we have to look at this we also. Okay, harnessing big data. Okay, okay. So these are some examples of big data analytics. Okay, so online transaction processing, online analytical processing, and real-time analytics process. Okay, all these are part of big data analytics. Okay, so okay, so first one is actually we have some operational databases, and we have to report human analysis on history data. Okay, historical data we will analyze, and then we will report it. Okay, then after some years, actually it changes to online analytical processing. Okay, so from the data warehouses, analysis of current data. Okay, they will analyze the current data and improve their business. Then actually nowadays real-time analytics comes into picture. Okay, so there is no mediators there. Okay, it's directly come to the uh, directly come to the client itself. Okay, actually the data model actually it has actually changed. Okay, so actually, when we talk about the data, initially, customer data or consuming data was generated through oh, people collect the data through interviews or some newspapers or mm, some television channels or direct interview or public data. So they gather the data and they will do some recommendations or they will do some analysis and all, and they will send the okay they will send the promotions or they will reach to the public through uh, these medias. Okay, these are printed medias or television media. But nowadays, actually, everyone is generating data. Okay, every single person is generating their own data. Okay, and we all are consuming that data. Okay, so initially it was few companies generating data, and all other are consuming data. Now all of us are generating data. Okay, every single person is actually generating data, and we all are consuming that data. Okay, so what's the, driving actually big data? So big data. when we come to analytics, actually we have two things: business intelligence and predictive analytics. Okay, so in business intelligence, complexity is less, and the business value also it's in a medium phase. Okay, so it actually comes in the it's actually have techniques like ad hoc querying, reporting our data mining techniques. So, we have a structured data from typical sources, and we have mid-sized data sets. We have to process that and generate reports. But when it comes to predictive analytics and data mining, we have optimizations and predictive analytics. We have to perform complex statistical analysis. All the type of data we have to analyze. Okay, but initially in business intelligence, we have some numerical data or structured data. It's all structured. We can simply do the analytics. Then, when it comes to predictive analytics, actually, its complexity and business value is very high, and it has a very large data set. Okay, and we have to process it real time. And okay, so when it comes to big data analytics, actually, time to time value is also actually increasing compared to data warehouses. Okay. Big data is more real time and natural than traditional DW application. Okay, data warehouse application. Initially, we were storing data in CSV files or Excel files or some SQL data sets or so. But now it actually changes. We are actually taking data on real time, and we are processing all those data in real time. Then traditional data warehouse architectures are not well suited for big data apps. Like initially, we have some applications to store data, and those are actually, for example, SQL was there, and initially we were using SQL for data warehousing, and nowadays it actually changes, and people are started looking at NoSQL and all. Okay. Share nothing massively, partial process, scale out architecture are well suited for big data. Okay. So this is the big data landscape. These are some apps which are used for big data analytics and all. And this is the infrastructures. And the technologies we are using is Apache's HPAC, and Hadoop is there, Cassandra is there, and also Apache Spark is there. So a lot of technologies are there to handle big data nowadays. And so when it comes to big data parts, actually, okay. So getting the first data, we are using these softwares like Hadoop, Vertica, MapReduce, uh, ETL, EZL, Teradata. So these are the platforms we are using to get the data and get the live stream data or real time data. And to process these data or get analysis of these data, we using Hive, SciPy. Okay, SciPy is a Python package, and we have MATLAB, and we have R. Actually, R 4.0 version is released recently, last year, and it actually doing a massive performance in statistical analysis and big data analytics. And then we have SPSS, and we have SAS also. Okay. So SAS is also actually after updating to the latest version of 9.4 and all, and also SAS VR and all. So SAS is also actually giving more better analysis, or it is actually grow to a better analytical skills. Then getting the deep insights. Actually, we are using uh, these methods like unsupervised learning methods, social media analytics, sentiment analysis, predictive analytics, BPO, business and intelligence, network analysis, and data visualization, and data simulation. Okay. So all these things are used for some particular business objectives only. Okay. So uh, okay. So the first one objective is to mass customization of services. Okay. So nowadays everyone is actually getting their own customized services from most of the global giants. Okay. Like we are getting our own offers and our own price for Amazon and Flipkart orders or products, and we are getting our own recommendation in YouTube or Amazon Prime or Netflix. Uh, and when we searching in Google, Google is also showing Google know you well, and Google is also showing some good recommendations on the right side. Okay. Then quicker response to marketing trends. Okay. So initially, trade marketing and all is actually a little bit doubtful, or we need to study the market and do it. But nowadays, there are a lot of applications are there. They will give you live trends and all. Okay. Then identify real-time cost optimization. Okay. So we can identify cost optimization based on the customers and Amazon or so. Faster and more accurate decision making. Okay. And better and more holistic R&D. Okay. And automatic supply chain management. These are some applications of big data technology. Oh, these are the business objectives for big data technology. Now, big data analytics with SAS. Okay. So what is SAS? From Wikipedia, SAS is a statistical software suite developed by SAS Institute for Data Management, Advanced Analytics, Multivariate Analytics, Business Intelligence, Crime Investigation, Predictive Analytics. Okay, so it is actually developed in 1966 to 1976. Okay. After that, SAS Institute was incorporated, and they are actually now working with or dealing with SAS. So, so actually, SAS is a very costly uh, software, and if you want a SAS enterprise version, so on, so you have to pay lakhs of rupees for that. But as a students for start practicing SAS or big data analytics or predictive analytics with SAS or machine learning or data science with SAS, actually SAS is giving you a university edition, and it's actually powerful software. It has less functions compared to SAS and enterprise version, but it's actually a powerful software too, and it's free. Okay, so SAS University Edition actually includes different SAS softwares like SAS Studio, which we will use for, or which is we are talking, which is generally we say SAS. Okay. Apart from SAS Studio, we have base SAS or SAS or Stat, or SAS IML or SAS Access, and several time series forecasting procedures from SAS ETS. Okay. So SAS ETS and all are used to model. Uh, model. Okay, they are used to model the complex time series data, and they are actually giving a real time forecast. Okay. Okay. And SAS is one of the global Fortune 500 company. Okay. So, when it comes to a SaaS platform, SaaS platform actually supports every phase of the analytical life cycle, from data to data discovery to deployment. Okay, from storing the data, identifying the data, grabbing the data, to deploying the model, we can do everything in SaaS and its versions. Okay, using the SaaS package, we can do all these things. SaaS is uh, SAS is a stable software. We can simply learn SAS compared to other softwares. But there are a lot of softwares are there like R and Python. They are two what we say. They are two top. using in the industry. Okay, Python is actually used by 70% of the data science industry actually, and then it comes to R. Okay, but SAS is actually mainly used in insurance and biomedical areas. Okay, so they are actually SAS is widely using, and they are processing their data with SAS only. Okay, so it's an means the advantage of SAS is like we are using biomedical data, or we are processing biomedical data using SAS, because SAS is more secure, and SAS has its own true values. Like if you are familiar with Python or R, those softwares are totally free, and when we say free, everyone can create libraries, everyone can create code without paying it. Okay, there are no so everyone can create libraries or functions in Python and R. So there are no, we cannot say that all the values. Okay, for fitting a regression model, R has two options, like LM function is there and OLS function is there. Okay, both are from different libraries. Actually, we can perform a regression analysis, and if we look at the results of these two packages or these two functions, then we will have a slightly changed values. Okay, means there will be a slight difference in two values or two package outputs. Okay, there won't be much difference if you sum it out into a three decimal point or so. Then there might not be a difference, but in the medical sector and all, it is not enough. Okay, we need more precision. So that actually SAS is giving. SAS is actually giving that much precision to our data. Okay, or analytics solution, because SAS in SAS only one library is there, which is actually created by SAS experts. No one else, no public creating packages or functions in SAS. So SAS is a more reliable, and it is actually widely using in biomedical areas. Then applications of SAS. Okay. So SAS is actually widely using in business intelligence. Okay. So business intelligence is actually the analysis of information related to business. SAS allows various business forecasting tools and services, and it actually allows you or gives you a lot of predictive modeling technologies or predictive models, and you can simply perform these predictive models. Actually, SAS indexes and all is actually simple, so we can simply perform these models, and we will get a good tabular outputs in SAS. Okay. Also, we can do a good visualization in SAS, and we can create reports out of this. Okay, and the SAS is actually giving some good options compared to Python. Like we can generate reports and all in SAS itself. Based on the analysis outputs, we can simply generate a report on SAS itself. Okay. So second one is predictive analytics. Predictive analytics is actually we are predicting about the future. Okay, it's like the um, like what a horoscope is doing. Okay, so we are actually predicting the future using the historic data. And with predictive analytics, one can actually draw several inferences from the data using some statistical tools. Okay. So, as an example, SAS is actually allows to develop predictions for future based on the past records. Okay. So we have a lot of predictive analytics tools or regression tools and ETL for forecasting and all. SAS is actually providing these tools, so we can simply do the visualizations. We can simply perform the analysis, and we can simply do the visualization, and we can show it as a report or dashboard to the concerned team. Then SAS is actually providing the multivariate analysis options. Actually, when it comes to big data, actually, multivariate analysis are having a dramatic role there. Okay, it actually has an important role. So, normal analysis is actually using few variables and all that even we can do with any simple softwares. But actually, when it comes to big data, we have a lot of variables there. We have a lot of variety of data is there. So several multivariate techniques are needed in analyzing big data. So for that also, SAS is actually allow you to do a robust analysis of multiple variables. Then SAS is actually used for improving services. Okay, different services. It actually uses to optimize different data or different problems to its powerful algorithms. Okay, so one such example is actually SAS has played an important role in optimizing the services. Uh, was in the case of this airline. Okay, they actually use SAS cost and profitably manage for improving their service and the ground handlers. Okay, so I like that lot of major companies or technology giants actually using SAS for their analytics and all, and as well as to improve their services. Okay, so and importance of data science for using R. Actually, these softwares like Python and R, they are also doing the data analytics, but they started started or they are developed or they show their power recently only, okay, in couple of years only. But uh, before this data science, the word data science is coined. Oh, SAS was the primary choice of analytical professionals. Okay. Initially, getting a SAS certificate programmer or analytical professional is a very big thing. Okay. So, initially, getting a SAS certification was really gives you a lot of opportunities, and it was established before. Before all these Python and was developed, and it comes in a it comes to play a major role in data science. Okay, so before the word data science was there, it was famous. Before that also SAS was there, and it was the primary choice in the industry. Okay, analytical industry. But after that, depend on the industry. Actually, they try to choose different tools. But there are many companies they are still using SAS because of its simplicity and uh, its efficiency. Okay, and reliability. That's an important factor in SAS. Okay, so SAS was actually used by statisticians who wanted to build powerful models, and they want to build powerful. Sorry, any questions are there? Okay, okay. So it was actually used by these people, statisticians, business people. They actually used to analyze their data, and they comes with predictive models using SAS. Okay, coming to 21st century, it has been an exponential booming data. Okay, so till that actually data is as I mentioned, the big data was not there. Like normal data is only there, and many few companies or business giants they analyze the analyze their data. The rest of the people they will simply store the data in purpose, and once it actually overloaded they will simply uh, fire the data, or they will simply scrap the data. But nowadays, everyone simply, everyone understand the importance of data, and they are simply analyzing their data. Actually, without analyzing the data, if we keep the raw data, it's actually simply it's a proper waste. Okay, it's actually useless. Okay, if we have a lot of raw data and we didn't analyze the data, then it's actually useless. There is nothing we are gaining from the data. Okay. Uh, okay. So when it comes to 21st century, then only there was a data boom, and that actually cases to increment number of software tools and programming language to uh, analyze the data. Okay. So still, SAS is actually doing a better job in the industry, and they are simply using this data. Okay. So these are some clients they are actually using SAS. Okay, you might heard about Gartner. They are one of the best analytical provider in the world, and they're actually saying that Gartner positions SAS as a leader in the magic quadrant of data quality solutions. Okay, the other brand is UNT. You have heard about that, and they are also saying that the data management opportunities that SAS afforded have been a real difference maker. It was the shot of adrenaline we need to reach our goal. Okay, and also Inter-Americans, they told that we choose SAS due to its vast tool set and high quality service, along with its demonstration of great feeling and remarkable reflection. These are some and words from the clients of SAS. Okay, or who use SAS for analytics. Okay, that's all from me. If you have any doubts, you can shoot.
Uh, Hello, sir. Can sir, can we take questions?
Yeah, sure.
Okay, okay. So if there are any questions on this, you can go. You can take either you can unmute your mic and ask your questions, or you can type it through the chat box. Okay, sir. I think there are no questions regarding this session. Probably because SAS may not be familiar to the
Familiar,
academic
yeah.
community. Probably
Yeah, true.
because of that. So,
Yeah,
thank you, sir. So we'll wind up the session, sir.
yeah,
Yes, sir. Okay, so we'll wind up the session now. Uh, thank you, sir, for delivering an informative session on SAS. So, thank you, sir.
yeah. If you can conduct more sessions on practical sessions, I mean, then we can get familiarized with SAS. And it's actually a funny language. It's actually a nice language to learn. And
Yeah,
the people
yeah,
who are equal, actually, they can simply learn SAS because we have a proc SQL option in SAS, and it's actually the SQL thing only. So people who know SAS or SQL, they can simply without studying SAS, they can simply get into SAS. Okay. Mm,
okay, 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 sir. So, okay, thank you, sir.
yeah. Thank you.
Okay. So we'll wind up the session now. for today, and tomorrow morning we will have two sessions. We have two sessions. Um, Tomorrow morning we have tomorrow morning and afternoon our sessions will be handled by Dr. Anish Kumar Ayamvalli. He's a chief architect of data semantics from in Bangalore. So he will be talking on cloud computing best practices and multi-cloud architecture and cloud native data engineering and data science. So that will be something more practical like sessions. When demonstration kind of sessions will be there. So uh, uh, I think the feedback link will be providing. It's already there on the chat box. Please provide your feedback, and we'll meet tomorrow morning 10 a.m. again. Thank you.